Hello and welcome back. My name is Amir and this is Project Euler series, puzzle number 37. So, truncatable primes. The number 3797 has an interesting property. Being prime itself, it is possible to continuously remove the digits from left to right and remain prime in each stage. So this, if we remove 3, it will be 797, which is a prime. Then we remove 7, it will be 97 is a prime, and then 7 is a prime as well. Similarly, we can work from right to left. So 3797, remove 7 will be 379, then 37 and 3. Find the sum of the only 11 primes that are both truncatable from left to right and right to left. Note that these numbers are not considered to be truncatable primes because they are only one digit numbers. So we will start going from 10 and we will go on until we get to the 11 numbers that are truncatable. How can we truncate? Basically, if I have this number and I divide it by 10 and put the remainder out, I will get to this number. And then if I divide it by 100 and remove these two, I will get to 37. Divide it by 1000 and remove these, I will get to 3. So this is going one way, and for the other one is just the opposite. I will divide this by 10 and now keep the remainder. Then divide this by 100 and keep the remainder. So I will keep 97, 7 and 797. This way I can figure out if the number and all its substrings, so to say, from left and right are all primes. So let's go and write that. Okay, first thing is that I would like to go and grab the isPrime function from here. There is a link to this video here that you can go and check how to figure out if a number is prime or not. But that's not our focus in this video. So make sure to check that if you are not familiar with how to check if a number is prime or not. Let's grab this, go here, and then we will start from 10 and go on. So like this, and I need to write this function. So let's say so here I am taking the remainder, which is this number. So if I have the number 3795, so if I have number 3797 and I divide it by 10, get the remainder, I will get the 7. So we are going from right, 7, then 97, then 797, and so on. If it's not a prime, then we are done. We have found a substring that is not a prime. We can skip, we're returning false. Otherwise, if that substring is prime, then multiply I by 10, like so, to go all the way from right to left. For the other case, so here we are checking if number is prime. This number is prime, then it's fine. Otherwise, we need to go to the next step. We would divide n by 10, so it will be this number, and then it will be this number, and then it will be this number. And if we pass all these states and all of them were returning true, means all of them are prime, then we would return true, meaning that our number is a prime. So to check it, let's comment this out and say if we can truncate that number. Was it 3797? Yes. So, and yes, we can truncate it. What about this number? This should be the same. Yeah, no, this shouldn't be the same because 9 is a number that is not prime. In the end, cutting from left to right, we will get to 9, which is not prime. So this looks fine. Let's get the sum here and uncomment this. Check this. We would get to this number, which is wrong. I need to say this is I, not 10, because we are going from 10 and we need to multiply this by 10, then 100 and so on. So this should be our way to do it. Now we got the right answer. So yeah, that's the way to do it. I hope you have enjoyed the video. The link to my GitHub is always on the description, and see you in the next video.